the topic that we have for today, an introduction to artificial intelligence, and specifically its aspect or one of its sub branches, which is machine learning. The one that I'll be showing to you for today is, in fact, co-authored by one also of the co-creators in Open which is Sir Melchizedek Alipio. And with that being said, no, let's start. Now, before I go into the actual discussion proper, no, I believe already at this point in our technological innovations, no, we can already perceive artificial intelligence to be as one of the common and mostly, in fact, available technologies that we can already have nowadays. In fact, we can even leverage this technology to be somewhat um, already at par with uh, 5G, Wi-Fi, among other innovative technologies whose main purpose is really for us to um, develop and even improve the overall well-being of humanity and society as a whole. No? But of course, being a technology, no, we see of course, everybody here already has that idealistic perception on what this technology has to offer, right? I mean, especially during the pandemic, we've noticed that one key player for this technology who actually made it popular again, is ChatGPT and OpenAI, right? And with the promises of what AI can offer to us, we see it to be, well, majority of us, in fact, see it to be that already next new shiny thing that is able to give to us whatever benefits that this technology is able to offer to us in all of the different subfields of society, such as medicine, commerce, and in our case, as engineers, no, communications, electronics, and technology. But of course, like all other technologies, I mean, I'm not sure if you have been also been aware, but not really much popular here in the Philippines, but in other countries, when the concept of 5G was introduced, everybody was at a rage for it. There were, in fact, some mixed opinions on what the technology is able to offer. I mean, some conspirators, in fact, would even say that 5G was the technology that would introduce to us extraterrestrial life form and communications, right? But it's not really that of a big deal right now, right? And similarly also to AI, we still have that um a bit of an unsettling feeling on why do we even want to pursue this? Is this really the right way for us to pursue as a society overall? Right? I mean, we are already familiar on what the media is able to portray the fears and possible restrictions, or not really the restrictions of it, but rather going beyond what human and limitations in general is able to exhibit to us. No? My point here, no, it answers the general question of how far are we going, how much is really too far, right? And one of the possibilities of having a dystopic future is still also there, right? But if we're going to look at it from a scientific perspective, we see that even if we are going to focus more on the machine learning aspect of what this technology has to offer them, it's really more of like, okay, computations, predictions, no, and overall logic. So meaning it depends on who you are talking to. AI can even just be that's even though it's a new popular thing, especially for those who are not familiar of it. Us here in the technology space, especially those who are working in the analytics field and in data science in general, no, would see this technology to be somewhat still um, that normal new thing that we have already been using for quite some time already. I mean, if we're going to be blunt at it, no, AI is just also another means for us to do computational processing. Right? So, in say, the perspective of mathematicians and statisticians, no, especially in the concept of how you apply machine learning, no, it's just a series of calculations and probability, right? But that being said, despite all of the seriousness of what this technology has to offer, what is the real thing or what is the real application on what AI is able to offer to us? No? Of course, we see one of these memes wherein we use generative AI to create the most obscure images that we can think about. I mean, I've seen also, and I believe some of you have also seen that there are even some posts circulating around social media wherein you can see the heroes of our peso bills singing to Lady Gaga. Have you ever seen Andres Bonifacio singing to Lady Gaga? So that's AI to you, right? Regardless of what perceptions that we have, whether we have an idealistic, um, uh, pragmatic, realistic, or even just humorous perception of the technology is already there. And it's already up to us as technologists, no, as engineers, to already reap what it can give to us, the overall net good, and what applications can now we use or we can have it used no, in whatever field that we want to pursue. Okay, so having said that, no, here's my overall topic that I'll be giving out for the next few hours. No, so I'll briefly discuss to you what is artificial intelligence in general because it spans it's a large field. You know. It's not really just about say even though my focus here is more on the computational aspect of AI, meaning machine learning and deep learning, it's not really just its only and sole subfield. You also have other fields, and in fact, these fields no, also merge with other non-technology related fields such as medicine, commerce, and even the arts, right? So I'll briefly discuss it to you here, as well as the brief history of this science overall, because even though it has gained popularity in the early 2020s, no, it in fact it goes way back, even up to the 1940s and 1950s. And then from there, discuss the different branches of AI. So here we'll discuss, okay, if machine learning is just one aspect of it, what are the other applications of AI with regards to, say, mimicking locomotive um, movements of the human body. That's also another aspect of it. How about the creative aspect of AI? Is there a means for AI to also mimic human creativity? So we'll also discuss it here. And from there, we'll now take a deep dive on one of its subfields, specifically machine learning, because in our field, no, especially as technologists, no, this is the most useful and practical out of all, arguably, in fact. No? So I'll briefly discuss what is machine learning, the different techniques on and tools on how you can use already machine learning, and finally, like all other technologies, give you a bit of a reality check on what AI can really do and cannot do. Because much like other technologies, no, such as remember when there was a boom in telecommunications wherein uh, 5G is already here and people are already thinking of the idealistic vision of what 5G has to offer, right? Some say that in fact it is 5G that is going to be the revolutionary technology that would introduce to us already Internet of Things and microservices, among other things. So notice also my focus is really more on the 5G aspect of it, so in telecommunications, but I'm sure you also know um, other technologies that would have a somewhat similar flow when society has already accepted it. And AI is no different, no? Okay, so what is AI? Is there really an absolute definition for it? No? This is a broad field of computer science. So definitely it stems its roots in computer science, wherein it is concerned with creating or mimicking human intelligence by creating intelligent machines. Okay? So this is the overall general definition of what AI is. Notice also that in this definition, there's really not much terminology related to using robotics, right? Because definitely, of course, and understandably, whenever we associate AI, we also consider robotics to be a part of it. But the overall general definition of it just tells us that it involves the creation of machines, mechanical or otherwise, that would allow that machine to mimic at least an aspect of human intelligence or human behavior. And with that being said, there's really no standard or de facto definition of AI. It really differs on who you are also talking to. Now, here are some of the sources that I was able to find. Number one, no, um, it is the ability of a digital computer or computer-controlled robot or perform tasks commonly associated with intelligent human beings. Notice that in this definition, there is already the inclusion of a robot that's able to perform intelligent tasks. Okay, but there is also another definition wherein AI is the simulation of human intelligence processes by machines. So, in one definition, AI can be considered as an aspect that is related to robotics, wherein robotics is used to mimic human mechanics in general, meaning how to move an arm, how to walk, how to run, and even how to speak. No? The overall kinetics of the human body, but there's also a definition of AI that would involve the overall human logic and human intelligence. Meaning, you create machines, intangible or otherwise, that is able to have that perception that as if it is thinking. Okay? Now, AI has also different aspects, and these are some of the four most common ones that I was also able to find. First one, AI is capable of problem solving and decision making. So these systems can analyze information, identify patterns, make decisions based on the understanding of what data you give it to. Okay? This allows them to make complex procedures or to tackle complex problems rather and perform tasks as if it is a human being that is able to perform said task. Okay, it's no longer that linear or procedural means wherein you have to do step one, step two, and step three in order to get to destination A, right? So it's not always that case anymore when we deal with AI. And with that being said, one aspect of it also is the ability to learn and adapt. So these systems, based on data and experience, allow them to improve their performance over time and adapt to new situations. So you can think also much like human behavior or even human intelligence, right? I mean, we won't be able to know that fire burns our skin unless we experience it ourselves. Right? Similar also to AI systems. It learns from experience, quote unquote, in the form of raw data. And much like human, no, so much like humanity in general or human beings, no, the decision making and analysis that it is able to perform is only limited based on what data you also feed it or feed it with. No? Now, another aspect of AI, I believe this is the one that is most prominent to us, is the imitation of perceived human intelligence. While not achieving full human intelligence, no, AI systems can in fact exhibit human intelligence. So there is in fact a difference. And this also begs the question, no, of the underlying philosophy also of artificial intelligence. What makes human human? What makes an AI system an AI system, right? Um, in our state of technology now, of course, we haven't yet achieved true AI. So the one that we have um, nowadays, especially in chatbots such as ChatGPT or Gemini or even in Copilot, no, these are not purely human or purely artificial in some philosophical definition that we want it to have. No? I do hope I make sense. No, my point here is that whatever an AI system is able to exude or exhibit, no, to us, no, of course, it is not purely sentient, no. So that's why also the definition of or the term perceived human intelligence also comes into play because us as human beings, no, we're able to perceive an AI system to be mimicking human behavior, no. And lastly, environment interactions. So AI systems can perceive their surroundings through sensors and interact with the environment through actuators. Now, take note that environment interaction here is also not limited to the physical world or to the physical space, right? Um, much like also humanity, you also need a form of sensor, quote unquote, or a means to receive input or stimulus for it to analyze and also to learn based on said stimulus. Okay, where am I going here now? Just because you are creating an AI model, for instance, it doesn't mean that it is not interacting with the environment, so to speak, right? In a model, think of it this way that a model, whether you create a model that is able to predict, say, the salary of X number of employees for X number of years, no? As simple as that application, there is already also a sensor in a way, right? In the form of a variable. I mean, a variable can arguably also be considered as a stimulus or as an input for the model to understand what it is able to perform and to adapt to. You know? So we can go as simple as having an analytical model or as complex as an Android. No? But all AI systems, in fact, share these four aspects. Okay? Now, as I've mentioned at the start of this session also, that even though there was a boom of this technology, especially with the game or the game popularity of OpenAI, this in fact has already been there for quite some time. No? And in fact, I'm showing to you here a simple statistic wherein each of the points represent the consider it as the technological milestone of AI. What are the different revolutionary products and services that made AI what it is nowadays? No? And you'll notice that it spanned even as early as not just the 1950s, but even the 1940s. In fact, you can even say that in some sources, AI was also there when electronics was also developed and being developed, in fact. No? So despite the boom of AI during the early 2020s, during the pandemic, no, through one company, OpenAI, no, through their product ChatGPT, the science, in fact, has already been there as early as the 1950s. And in fact, like what I have said a while ago, it can even span as early as the 1940s. No? And this even is just the recorded technological timeline that we have as of the moment. If you can even go way back, the concept of AI in the form of robotics, quote unquote, no, robotics, has also been there since antiquity, right? If you are familiar with Hebrew mythology in general, they have what are called golems, which are um, human-like figures that are made from clay, no? And whatever it is, that is whatever symbol that you place on their foreheads are the ones that would be you are essentially programming that golem to do a specific task, no? And take note, this is in as early as I don't know, early 80s before the Common Era, in fact. So that's just one example. And you can also cite other examples in Western mythology, like in Greek or even in Roman mythology. Okay? So we in fact no, owe it to OpenAI to making this technology popular again. No? Now, AI in general, because this is also a science and it covers several aspects and several subfields, no? We can already consider it to be more than um, a field that is just isolated to computer science. In fact, no, AI in general can even span in the non-sciences or even in the arts, right? There's even what is called the philosophy of artificial intelligence. In one of the points that I have mentioned a while ago, one of the rising questions on the philosophy of AI is that what makes a human, what makes something sentient, among other questions. I'm sorry, I'm not here also to discuss what those are. I'm not a philosopher in overall, no, but you get my point here, no, that with its intricacies, no, this science can already span in science and in scientific engineering and even philosophical disciplines. And some of these, in fact, also overlap with each other. No, I mean, if you're going to look at it, no, if you're going to build, say, a simple Android that is able to greet visitors, so perhaps a kiosk, so you have an Android there, and what they are just doing is to greet them to do some simple question and answers. No, you are already thinking of not just mechatronics or robotics because you also need to have that mechanical aspect of it. You also have to consider the overall behavior and face of the Android itself, right? So meaning that, of course, you don't want that Android to be greeting you to be in a smug, right? So of course that would have um, the perception that the Android is not feeling too good, right? And just that simple interaction, we are already diving deep on the psychological aspect of AI. No, so it's already not just focusing on the computer science aspect of it in general. Okay, so however, for our case, no, especially for us who want to pursue a path on data science, such as myself, and even data science and data engineering, no, we want to focus more on the machine learning aspect of AI, meaning we want to create models that is able to mimic human intelligence, no matter how simple or complex it is. No, now um, as I said also a while ago, no, when we talk about this technology, it's also evident that the terminologies of machine learning, deep learning, neural networks, no, clustering, regression would also come into play. So I'm here now to set you some pictures. No, what are the different relationships of these terminologies, especially the big three ones? No, AI, machine learning, and deep learning. How are they related with each other? So, like in my previous slides, no, we can consider AI to be that broader umbrella concerning with the creation of intelligent machines. And we can consider this to be the overall, the highest peak. In fact. If you're just going to focus on the logical aspect of AI, meaning you want to create an intelligent machine that is able to mimic human logic or human intelligence, then you are already dealing with machine learning. Okay? Now, by its technical definition, this is a subfield of AI focused in developing algorithms that can learn from data and improve their performance without explicit programming. And take note of the term explicit programming here. When we are already using machine learning, we are no longer confined to creating models that is able to run procedurally, meaning that I believe some of you here have already experienced writing their first C program, right? Wherein, say, you create a C program that displays the message "Hello World," a classic, no? But if you're going to look at that program, no, you'll notice that the code that you have written operates procedurally, meaning normally from top to bottom. Right? Depending on the complexity, if you have for loops and such, no, you are thereby directing the flow of that program. But the point here is that in a typical program or application, it runs procedurally. Contrary to that, machine learning, you create a model, you give it a specific calculation, and this calculation can come in the form of a function. And based on this function, the model is now able to say or to respond, based on other data that it has previously gotten, dependent also on the function. So you'll notice that I'm already also aligning my terminologies with mathematics because yes, machine learning also deals with mathematics. And having said that, no, one application or one approach to machine learning is to create a series of functions that you then interconnect with each other in order to create or to have a expected result. This stitching together of functions, you form what's called a network or a neural network, is now the subset of deep learning. So this is now where machine learning and deep learning are now interrelated. You can say that deep learning is a subfield of ML, inspired by the structure of how a human neuron would look like. So later on, I'll be showing to you here also some slides for it. It utilizes artificial neural networks with multiple layers in order to process data and to learn from intricate patterns. Okay, now let's now go into machine learning. This in itself is a science that is also a beast on its own, meaning that it has also, there are a lot, in fact, of studies here. No? I, for one, no, I'm taking up a master's in TUP Manila, and I'm taking up my master's in data science and engineering. No? And this is a course that is intensive on creating machine learning models rather, in order to solve real world problems. So, for example, here one of my classes, in fact, so a bit of a story time here. One of the classes that I had, allowed us to create a model that would say predict the power consumption of a given data center just by looking at its overall workload. Right. So because my industry field is more on virtualization and data center management, no. Of course, we need to understand in my field of work, I've seen that one of its applications is okay, I have virtual machines running on this server, and just by looking at the overall CPU utilization of my server, how am I able to predict the overall power consumption of the entire data center that hosts 1,000 or even not just thousands, but hundreds of servers? No? So this is where the concept of machine learning can be applied to, and wherein you can also apply in your respective fields. No? Now, there are two techniques in machine learning based on how you now train the model. So remember what I mentioned also a while ago, that in machine learning, you create models. It involves the creation of um, models wherein it is also associated to a mathematical function. Now, there are two techniques based on whether how you train that said model to produce a result. Okay? And those two techniques are called supervised and unsupervised. Now, for supervised learning, there are also several techniques that are available here, but I'll discuss the two most common ones based also on what kind of data that you want to produce. In supervised learning, if you just want to have an overall prediction, meaning I have this data X and then I feed it into my model and it would produce a value Y, then that is what is called regression. Okay? So meaning you feed it with a value, the model would produce an equivalent value for it based on the data that you have previously fed it to. Okay? If, say, I have data X and then I feed it into the model and I want that model to classify X based on class A or B, so meaning I feed my model with data X and then it will tell me whether it belongs to class A or class B, then that technique is called classification. Okay? So later on, I'll be going in dive deep on these two. No? So this is the two most common techniques for supervised machine learning models. Is it possible for me to just create the model and allow the model to learn based on the data that I feed it with? The answer is yes. This is where unsupervised modeling or unsupervised machine learning would be coming in. And much like supervised learning, we also have the two most common techniques here. Okay, so if say you have series of data X, Y, and Z, and you want to understand how X, Y, and Z is related with each other and how close or far apart they are based on a certain parameter, then what you are using is clustering. Okay? So in my simplified example, I only have three data sets, but say I have 1,000 data sets, for instance. And then I create a model that is able to identify if there are some commonalities across my data set. And from there, see if whether some data sets are clustering together when I graph it. No, this is where obviously clustering would be coming into play. If, say, I have a data set and I want to know if by getting data X, do I produce the results of Y? No, this is where association rule would be coming in. So I'll explain all of these ones later. No, but first off, let's go into supervised learning. So this is the technique that involves the creation of models based on the evidence of uncertainty. Prediction. Okay, so that's where supervised learning would be coming in. It is an algorithm that takes a known set of input data sets and known responses for your output. And based on this input and output, the model is able to generate reasonable predictions for the new response to new data. Here's an example. Um, Suppose I create a simple model that is able to identify whether this model is able to say whether is it a cow, an elephant, or a camel. Okay? Now, we all know that these are all four-legged creatures, right? But we also know that there are some traits of what a cow is, what an elephant is, and what a camel is. We know that if that four-legged creature has hooves, no, it's able to produce milk, is normally domesticated and found in farms, then we know that it is a cow. If say it is a four-legged creature with a long trunk, it's an elephant, and obviously, um, if it has a hub, no, can be a pachyderm in general, but if it is normally found in a desert, it is a camel. So in supervised learning, we feed the model with these data sets. Meaning, for example, if one data set that you would feed it, if you see this picture, this is a cow. Okay? If you see this picture, this is an elephant. If you see this picture, this is a camel. And you feed all of these data sets into your model. So that when you now feed it with the actual input, so now um, you now give it another picture. Now tell the model, what is this animal? Is it cow, an elephant, or a camel, or something else? You'll notice that in supervised learning, no, it's much like how you would also teach a 4-year-old to identify animals, because that's what supervised learning is also about. No? So what we are also doing in the academic space is essentially supervised learning. In a typical classroom setup, you teach the students what is wrong, what is right, how do you classify this and that. No? It is also the similar analogy to supervised learning. Okay? Now, there are some two, or as I mentioned a while back, that you have two main classifications of SML, or supervised machine learning. You have regression or classification. These two differ based on, okay, you feed it with data. Now, what outcome do you want it to produce? Based on the data, do you want it now? Do you want the model now, rather, to make a new prediction? So this is where regression would be coming in. Or you feed it based on that data, and then you give it another set of data, no, able to classify based on the learned data. This is where classification would be coming in. So regression is a type of supervised learning technique that is used to predict continuous values. Okay. Normally, this is also where the concept of predictions normally used in stock markets, for instance, no, is being applied to. And you'll notice also, does the graph look similar to what you would see in your linear algebra? I mean, you have a straight line, right? Because yes, regression is in fact the application of linear algebra. You have a slope and you also have an offset value, mx plus b, right? And this is essentially what is the function that you are teaching your model to learn. Okay. Now, what makes this different from your, say, elementary algebra is that you're no longer just dealing with one set of data, but rather a series of data sets, right? And with that also being said, you can also further optimize how the model is able to perform just by looking at the graph alone. This is where the concept of exact fitting, overfitting, and underfitting would be coming in, but that's in fact on a different way. So my point here is that regression is in fact just an application of your linear algebra. No? How about classification? This is the process of finding or discovering a model or function that helps in separating the data into multiple categorical classes. Remember my example a while ago about sorting four-legged creatures? That is, in fact, classification at play. In classification, data is categorized under different labels according to some parameters or characteristics, no, given in the input, and then the labels are predicted based on those things. Okay? So, in supervised machine learning, whether you are using regression or classification, no, the point here is that you feed the model with known data. By known, meaning that you feed it with an input with the desired output that you want it to learn. Okay? How about unsupervised learning? So, much like how the term goes, no, unsupervised learning, you create now a model, but that model, you still feed it with data, no? But the task of the model now is to group unsorted data according to similarities, patterns, and differences without any prior training data. How does this one now look like? Suppose now you have or you create a model and then you just feed it with a series of data that consists of pictures of four-legged creatures. Okay? And a caveat here is that, okay, just because it is unsupervised learning doesn't mean that you are already giving full independence to that model to learn on its own. Remember that you still have to set certain parameters in this form, thresholds, for that model to understand how it is now able to produce that set data or the outcome that you want it to have. No? So here's an example again. Suppose I have a data set that consists of pictures of four-legged features. I also set a threshold in my model wherein if, say, my threshold is associated to color, for instance, color, and the color that I have set is color brown. So what the model would then do is that it will try to make sense of these data sets and based on my parameter, if it sees a picture that is more brown than others, no, have it as plotted in my graph in this form. Okay, so that's how super unsupervised learning works. No, and much like supervised learning, UML or unsupervised ML also has two most common techniques. No, notice that I also set a threshold. No, and the outcome of this model is to produce um, similarities or differences on my set data. This is also where the two techniques would be coming in. Okay? And in fact, the one that I'm describing a while ago is clustering, the clustering technique. So these algorithms work by iteratively moving data points closer or farther apart to their cluster centers or further away from other points in other clusters. In other words, you're trying to group your data sets, no, based on a set threshold, and this threshold can then be used by the model in order to group together or cluster together, no, some commonalities. Okay, so the specific value on what you use for this clustering technique would also depend on your requirement. Okay, what is the other one? You have association rule. So this is also a type of UML that checks on the dependency of one data item to another data item. So this means that in association rule, you're trying to find an association based on the data that you have fed it with. Okay, here's an example. Suppose I have four simple data sets, right? And those data sets consist of information from four customers. So we are working with a grocery here, no? Customer one, two, three, and four. Now, customer one in their shopping cart, and you're trying to now, the objective of this model is to identify whether if a certain customer purchases a certain item, what's the likelihood of them purchasing another item? So association comes into play. In my example here, now customer one, what they've bought are only three items: milk, bread, and butter. Customer two, four items: milk, bread, cereal, and butter. Customer three, milk, bread, and butter. Customer four, sugar and eggs. Now we answer or we ask now the question: what's the likelihood of a customer purchasing milk and bread along with butter? That is how association rule works. Here's a more model or here's a more a bit scary example, no? Suppose you log into say or suppose you go into Shopee, for instance, no? And you type into your search bar, say, printed t-shirts. Okay? Printed t-shirt lang. That's the only item that you have typed. And of course, what the app would do is that it would produce a set of items related to your search word, printed t-shirts. Right? If you click a certain item, you'll notice that below it, no, it would also suggest you other items that you also might want to purchase along with your printed t-shirt. That's how association rule works, no? Especially in e-commerce. Here's a bit more scary thing, no? And I believe some of you are already aware of this, no? Suppose you log into Facebook and say one of those notorious ads about about let's use Shopee again or Lazada. Suppose you have logged into Facebook and then the ad of Shopee appears, no? And then it has stayed into your screen for a certain amount of seconds. Now, you don't want to scroll in Facebook anymore. You close it and then you go into Viber, okay, or even WhatsApp. No, you'll notice that why is it that Viber? Okay, I've seen Shopee or Lazada's ad in Facebook. Why is it that when I log in now into Viber, take note who already also runs ads, no? It's also trying to show to me the same ads for Shopee and Lazada. No? So that is also where association rule is coming into play. It is where these e-commerce platforms are trying to make sense of what we are trying to purchase or intend to purchase, no, just by showing to you a certain ad, and based on the duration of that ad um, being displayed into your screen is able to pass that data into somebody else. No? Another classic example here, suppose you've tried to search for a cell phone case, or you're trying to look for a cell phone case in Lazada, for instance, and then you see that the 10/10 sale is not yet here. It's already October 12th, by the way, so it has already passed. You log off Lazada and then you go into, say, YouTube, for instance. Why is it that YouTube now is showing to me ads about a new cell phone case, no? Or for instance, Caseify, among other things. Yeah? So how is it that these e-commerce platforms is able to learn what I search from one platform and essentially carry it over into their platform when I log in? So association rule comes here. Okay? So there, so algorithms in fact can in fact also be also an application of machine learning. How YouTube also suggests to you other videos is also an example of association learning. Okay? Now, um, whether you want to have regression, classification, clustering, association rule, among other things. So you have also the liberty on how you can apply them. Do you want to create a model that is just consisting of a single function? Okay. And this function is just a mathematical representation? Or are you dealing with more complex data, such as a picture or an image, no, that a single data point consists of a pixel, and of course we all know how complex a single 4 megabyte pixel is, no, able to predict other outcomes. So this is where the application of deep learning would be coming in. Sometimes when you create a model, it's not enough that you have that model be just a single calculation or a straightforward mathematical equation. Sometimes you need a series of calculations interconnected together, and based on the result of one calculation, have it forwarded or fed forward into another that would be the input of another function, and so on and so forth. In other words, you're creating a network, no? And this is where deep learning would be coming in. And in fact, this is also where most of the applications of image recognition, speech recognition, voice processing, no, would come into play. Because remember, when you're dealing now with images or voice, no, a single data point or a single data set can just be a single pixel. No? Or in your in a voice recording, no, A data set can just be a single spike in your what you call this sound file. No? So what is deep learning in general? This is a part of machine learning that uses AI or ML to learn lots of data without explicit programming. So again, the definition is still here. The only difference is the approach. Okay? Wherein in deep learning, you now cascade together several functions and form a network. Okay? Deep learning needs lots of data, labeled data, and powerful computers for it to work well. This is because you are essentially working with functions of a function of a function, or the result of a calculation to another calculation to another calculation. Where am I coming from here? No? Deep learning, in fact, took its inspiration from the structure of the human neuron. So already I'm throwing my caveat here, no. I am not a medical person. I'm just showing to you here for for analogy purposes. Here's a picture of a biological neuron, no. This is the cell found in the human brain. And structurally speaking, no, you can say that a neuron consists of three basic parts, no. Again, I'm already throwing my caveats here, no. Forgive me if my definitions here are a bit too simple, no. So a neuron would consist of dendrites. So these are the fibers that are used to receive signals from other connected neurons. You also have the soma, which serves as the body of that neuron. And finally, you have your axons. So the axons function technically like a dendrite, but its main purpose is really as terminal points connecting to other neurons, or if it is towards outside the brain, for instance, or to the spinal cord, no, to other glands. Okay, so you have dendrites that would receive signals, the soma, that would be the main body of the neuron, and then the axons, or the terminals. With the structure, same structure, you can in fact create an artificial neuron based on these three. It now looks like something like this. An artificial neuron consists also of your quote unquote dendrites, which are your input layers. No? You have your soma, which is the summing function or activation function. And finally, the output, okay, or the output node. Okay? Each neuron in some textbooks define them to be nodes. No? Now, in an artificial neuron also, you can consider that the dendrite portion of it is broken down further into two parts. No? You have the actual input node. This can be from another layer, no? And it is, I would say, multiplied, no, to an input weight or to a bias. So this is where the input weight would be coming in. Okay, so notice the similarities of what a biological neuron would look like to an artificial neuron. So of course, you won't be able to see a chip that has an artificial neuron. This is also a logical representation of it. The point here is that it shares a same structure of what a neuron would have. No? And you don't just work with a single neuron. You work with a cascade of it. So this is where neural networks would be coming in. A neural network normally is used to describe layers. No? So you can also associate neural network to layers. No? You have there first off your input layers. This is where your pixels, if I'm working with an image, no, this is where the raw data or the pixels will be coming in. And then these nodes or layers are then connected to a series of processing layers, let's put it at that, no, that is now used to make the prediction or classification that you need. Okay. Now, in definition, these processing layers are called hidden layers. Aptly deemed so because you, as the developer of the model, the creator of this neural network, you don't really need to bother too much on what goes underneath these hidden layers. This, in fact, depends on the kind of algorithm that you want to work with when you're already applying the neural network. Okay? And oftentimes, it deals with more than one hidden layer. Finally, after the hidden layers, it then would produce a result. Now, this is now called the output layer. And this is just in fact, a simplified representation. No? But how will now this work? Suppose I have a given image of the front of a car, no? And you're trying now to create um, a neural network that is able to isolate a portion of that image just by looking at the portion of concern, the number, or yung the car plate. Okay? So us, we know human beings that normally the plate can be found on underneath the hood. Tama ba ako? Tama ba yung terms ko? No? Just below the face of the car. Okay, but this is based on our human intuition. The challenge now here lies on how do we now train a neural network to look at it that way. So think of it this way: each of that given pixel in your image, no, is represented with a single data set. All of these are fed into your input nodes. Notice that the input node consists of the actual data set along with a weight. Okay? Now, the weight is then multiplied to a single data set and then added with a bias. Notice the formula for how a neural network does its computation. It looks somewhat familiar, right? Dare I say it looks like the linear function y is equals to mx plus b in your linear algebra? Because yes, it is, in fact, its application here. The only difference in a neural network is that you then perform a series of calculations, of linear algebraic calculations, without for you already understanding or even bothering on how this is being done. It's already the job of that neural network to do so. All you have to do is to feed it. So when you create a model or instantiate a model, all you have to do is to feed it with whatever data set that you want it. And then from there, the neural network is then able to understand, okay, just by looking at the hidden at just by doing the calculations on its hidden layers and then produce an outcome. In this case, you want to isolate which location in your picture can the car plate be found. Okay? To simplify how the processing of the neural network um, does it, no, within its hidden layers, no, similar to how a network would be functioning, no, it is also cascaded. So it is fed forward or fed to the next layer, no. There are also, in fact, some algorithms and models that feed it backwards. So meaning after it has already gone through all of the hidden layers, some models would even feed it back into the model recursively in order to perform error checking. So this process of feeding it forward and then at the end or in the last layer, for instance, no, temporarily feed it back is what's called backpropagation. This is normally done by the model in order to do some error checking before it can produce a final result. So feed it forward a bit, feed it one layer back, and then feed it forward again. Okay, so that's how neural network works in general. Okay, and from there it can already produce the result that you want. Now, fortunately, also for us, you don't need to create models from scratch. No, there are already in fact available tools and um, websites wherein we can already harness or utilize neural networks based on whatever requirement that we need. No, for example, here, no, ChatGPT is not just limited to a chatbot. No, in fact, no, ChatGPT is the chatbot front of it, but it works at the back using a generative AI called GPT 4.0. GPT 4.0 is the model that you use to function ChatGPT. Much like how Google, when they had uh, Gemini, back then it was called Google Bard, no? When they had Gemini, there I believe the underlying model that they have then is Lambda, if I'm not mistaken. Lambda, no? Another example here would be Facebook, no? Meta. So what we have is the Llama model. So these are in fact already available neural networks for us to use. Okay? So why am I saying all of these terms? No? The point here is there a one size fits all algorithm? Obviously, there's nothing. No, there's no such thing as an ideal one size fits all. Even if you have ChatGPT here, you'll notice that it still has its own limitations. In fact, chatbots are normally used for um, simple Q&A. No? And then it just depends on what type of topic that you want it to answer. Mostly anything under the cloud because it uses the internet as its data source. No? The point here is that understand your data first. So this is also the reason why we are introducing to you several techniques and algorithms because, example, you want to create a model that is able to um, predict what would be the outcome of, say, the recent oil price hike. No? How will the oil price hike affect the prices of groceries, no, in supermarkets? Will you be using classification as your model for that? Of course not. You'll be using regression. Suppose I have a set of students. So if you are working in the academy and you have say five sections and you want to overall sort your classes based on their level of comprehension on a certain topic. Do you use regression? Of course not. You use classification. Okay? So the point here, understand your data first before you can even learn or you can even use what kind of machine learning technique you have. Because in fact, there are a lot of techniques available. So as shown here in the diagram. Okay? Now, much like other fields in computer science that deals with data analysis, because that is what machine learning is, no? It relies heavily on data. It is also implied that common practices for data science and engineering should be applied here as well. Meaning that it's not enough that you just have your data. You also have to do some pre-processing or in some terms, data wrangling before you can even feed it into your model. This is also why in your typical machine learning workflow, no, you're not just concerning yourself with creating the actual model. You also need to understand the data that you'll be working with. And at the same time, no, um, fix or clean out your data before you feed it into the model. Remember that AI would only produce the results that you want it based on the data that it has. Okay? It's not omnipotent. Okay? It cannot learn from nothing. It needs to learn from something. That's my point here. And having said that, I think I'm down to the last few slides here. No, much like all other technologies, no, machine learning and AI in general poses their own sets of limitations, and in fact, no, some of them can be a bit controversial to say the least. So I'll be citing to you here some, some points to consider. And number one, elephant out of the room, no, ethics. AI algorithms, again, depend on the data that you feed it to. Therefore, certain biases and sidings, if there's a right word for it, no, certain biases, no, can present itself, especially when you are working with your data. AI systems can also raise concerns about data privacy and security. This is also the reason why there are already with the sudden surge, no, of AI being a popular technology. This is also where some legislations and some initiatives by governing bodies are already putting into play data ethics, no, AI ethics, and AI security. Okay? Another limitation, deterministic problems. No? Just because an AI machine is able to function logically doesn't mean that they are always factually correct, right? AI and machine learning excel at finding patterns. Yes, they are good at it. No? And in fact, they can even surpass what a human can do. However, when it already deals with logical reasoning or even just plain common sense, no, um, it's somewhat still a developing aspect of it. Let's put it like that. Okay. Another one is correctness and completeness of data. Um, Especially when you are working with chatbots. So chatbots. No? So here's a common practice for us, especially us nowadays that we are almost working with ChatGPT or even Gemini on a day-to-day basis. No, always check the sources. Okay, sometimes generative AI, such as the one that we are using for chatbots, it can produce inaccurate or incomplete or even biased data. If you are in the academic space, of course, some of us use ChatGPT to say create our, and especially in the research and development field, no, you are working with or finding out your related literature, for instance. No? So it's already easy for us to just type a prompt of create a review of related literature for topic X, Y, and Z. And then immediately ChatGPT would produce to us the full chapter two of our paper. No? But again, not all of the sources it has produced is also factually correct. No? And this is where the concept of hallucinations would be coming in. Okay, sometimes the URL links that these chatbots produce lead to nowhere. I personally also experienced this firsthand also, no, when I am trying to look for sources for also for my research. Now, some of them, in fact, lead to correct or okay. The scenario of chatbots here, for instance, no, is that there are some instances wherein it would produce a URL that is completely broken, and some of them would lead to a different site, but in a completely irrelevant topic. So, for instance, no, just I think just a few months ago, I was looking at the topic on cloud computing, and it produced to me a research paper for cluster computing. Take note of the term. I used the term cluster computing. No, so it produced a result. It produced a URL. But when I clicked the URL, it led me to a research paper about cluster management that is more on the aspect of farming and fishery, which is not what I wanted. Okay? So, correctness is still an issue here. Next one, misuse and misapplication. If you've already heard of deepfakes, and fabricated information, anything nowadays can already be fabricated with the right tools, no? Unfortunately, AI is the exception. Okay? There, in fact, are some ethical and controversial issues that was raised, especially with the dealings of POCs, person of colors, race, religion, even politics, no? And lastly, interpretability. Um, Having a so remember my topics about or my talk a while ago about deep learning, wherein all you have to do is to create a model or to call on a model, and you don't really need to bother on how that model works or functions because you have the hidden layers for it. No, all you need to produce is the result. No, now that convenience in a way is somewhat a double-edged sword. Why is it? No? Because some AI models can be quite complex and opaque, such that you no longer understand how it works in general. No? This can impose a lack of interpretability, especially to those who are using the model, because it can hinder trust and accountability. How is it? No? I'm not sure if some of you here are into, or if some of you are content creators in YouTube or TikTok or Instagram or wherever, what have you, Of course, your objective as a content creator is, of course, to lead or to garner followers, right? So you'll notice that there are, in fact, some dedicated channels and uh, content creators wherein they give out information on how you can quote unquote hack the system or hack the algorithm so that you can gain more followers. Follow for follow, among other things. No? Now, why are they even imposing it here? Because from their perspective, the algorithm of their social media platform is completely opaque. They don't have visibility on how it works, and rightfully so, because you also need a way for also to manage and control how a certain user is able to use the said platform. It's the same also here in machine learning. No? With the problem of, or with the convenience of no longer doing much of the calculations, comes the price of opaqueness and complexity. This also comes into play wherein if you're trying to do a simple calculation, you don't necessarily need to create a neural network just to perform said calculation. Okay, that can be a bit of an overkill already. Sometimes a simple linear regression model is sufficient. Okay, because you want to avoid this chat. Okay, so that was a bit of a long stretch, no? So what have we learned for the last few hours, no? So I've learned or I've shown to you what AI is as a science. We took a bit of a history recap on this technology, focus also more on its applications, its strong points, and even its limitations. And then about machine learning, which is a subset of AI, understood its different techniques and where can we best apply a given technique based on that given calculation.